Hello everyone. Today I will introduce our research on using XR technology for construction safety training. The title is Virtual Interaction on Concept Running for Construction Safety Training. So this is the index. So I will progress from the introduction. Construction sites are high-risk environments where the proper use of personal protective equipment, PPE, is essential. However, traditional training methods primarily focus on theoretical learning, often lacking hands-on experience. So this gap in training can lead to improper PPE application, increased accident risk, and the lack of situational awareness on site. To address this challenge, we explore extended reality (XR) technology, which offer immersive and interactive learning experience. XR enables learners to engage in virtual yet realistic environments, making safety training more engaging and effective compared to conventional methods. Additionally, embodied learning theory suggests that physical interaction with the training material improves retention and decision-making skills. By incorporating embodied interaction into XR-based training, we create a more engaging and effective approach to safety education. And this is a research objective. So our study aims to develop an XR-based construction safety training program that enhances learning outcomes by integrating physical and virtual environments. So this approach allows learners to practice safety measures in an intuitive and engaging manners, reinforcing both conceptual understanding and practical application. The XR training programs we developed simulates 3 construction tasks: painting, welding, and power drilling, and each task progresses through the 4 structured learning phases. So first is task presentation. So learners observe unsafe practice in a virtual construction scenario. And second, risk evaluation. So using an interactive checklist, so learners identify potential hazards and determine appropriate safety measures. And third is PPE applications. So learners select and apply the correct PPE on a physical mannequin, so ensuring alignment with the proper safety protocols. So last is feedback and result. So the system provides immediate feedback, including animated demonstration of a correct PPE applications. So let's look at the details. So task presentation. So this page presents a realistic problem scenario to engage the learners in context-based decision-making. So the goal is to encourage appropriate PPE selection in practical situations. For example, in these pictures, so one scenario involves the Mr. Tashi Kim, a cafe owner, who is repainting his cafe interior using industrial oil-based paint. Because the interior innovations are expensive, the do-it-yourself projects are common, right? So the scene immerses the runners in a realistic workplace hazard settings, some preparing time them to make informed decisions. So next is the risk evaluations. So learners use a checklist based on Korean Occupational Safety and Health Agency, so KOSHA, guidelines to identify workplace hazards. So Mr. Tashi Kim, for example, is using industrial oil-based paint, which is toxic if inhaled or comes into contact with the skin. However, he's not wearing a gloves or some respirator, so putting himself at risk. The system prompts the runner to identify hazardous elements by marking risk areas with circles. If the runner selects the correct risk, the system acknowledges it with visual feedback. If incorrect, immediate corrective feedback helps guide them to the right choice. Next is the PPE application. This stage provides an augmented PPE storage units where user can interact with virtual protective equipment. Learner can grab, lift, and move PPE items in the virtual space. Then drag and drop the selected PP onto physical mannequins, aligning it with the correct body parts. If the task is completed successfully, the digital human avatar of task Kim appears, and he will be shown wearing the correct PPE and safely continuing his padding task. If the runner fails to applying the correct PPE, the system explains the potential injuries associated with the incorrect PPE using. The runner then has the opportunity to retry the task with a better decision making. So if a user fails twice, additional support is provided. So first, in these pictures, the pop-up explanation appears for each PPE items, some describing its purpose and importance. And second is running materials. Function allows user to review detailed PPE guide and image at any time. So XR technology implementations. To enhance learners' effectiveness, our programs integrate key XR-based learning tools. So embodied learning through physical virtual integration. So learner engage with a real mannequin while interacting with a virtual PPE, ensuring deeper cognitive engagement and skill retention. Real-time feedback system. So immediate guidance helps learners refine their choice and develop critical thinking skills in safety management. Last one is a gesture-based interaction. So using HoloLens 2, the runner manipulate virtual PPE in a natural and intuitive manners, bridging the gap between the digital running and the physical operation. So research finding. So our research finding demonstrates that XR-based training offers significant improvement in safety education by focusing on three key outcomes. First is improved practical learning. Learners can apply safety measures in realistic immersive environments, which enhance their ability to perform correctly in actual work settings. Second is better hazard recognition. So through repeated exposures to simulate hazards, learners develop sharper risk awareness and are better prepared to identify and mitigate dangers on the job. The reduction in workplace accidents, so by reinforcing proper safety behavior and encouraging PPE creations through hands-on practice, XR training contributes to safer workplace behavior and fewer accidents. This study demonstrates that XR-based training enhances engagement and effectiveness compared to traditional methods. By integrating embodied learning principles, we create a more effective and retention-driven training experience. So moving forward, we plan to enhance the program with the following improvement. So avatar representations, introduction of mirror function to allow learners to see themselves wearing PPE, so improving self-awareness and immersions. And enhance failure simulation. So adding a realistic failure consequence, such as the visual distortion or simulated some injury to reinforce the importance of PP compilation with some haptic, and this is features. So user feedback and UX enhancement. So gathering learners' feedback to refine the interface, improve usability, and tailor training experience. So closing remarks. So in conclusion, XR-based training is a transformative tool that extends beyond simple knowledge transfer to actively changing learners' behavior by combining interactive digital environments with physical learning. We offer a highly effective and engaging approach to construction safety training. So we will continue refining our system and exploring innovative way to enhance safety training through immersive learning. So thank you.